Now 28. Which one class it is? It's ninth. Or it's any other one class. Ashmandeep, hello. How are you? Daman, hello Daman. Savan Singh, good morning. Pohan, hello Pohan. Manjot Man, good morning everyone. Tell me whether you are enjoying your online classes or not. Gurmannat Singh, good morning. So how many are getting online? Still we have to listen. You have to help the other also, so as to get online, because still we are getting very less number of students. Today is 12th. Okay, today we are going to study about Newton's second law. The third one question which I asked you, that how time force is dependent upon time period, because this one is a very important question. A lot of questions may be asked regarding this one. 9 students are there. Thanks for coming over here. 9 students we have got. We will wait for 1-2 minutes more. Okay, so now we are going to start. Okay, so now we are going to understand Newton's, Gurleen, good morning, Newton's second law. Okay, So in this one, what we have to understand, oh my goodness. Pohan, still video problem is there or not? Because here there is no problem of any video. There is no problem of any video. Okay, so let us continue, because Newton's second law I was going to elaborate. Just been there, good morning. So what do the Newton's second law say? They say that force is equal to change in momentum divided by time period. Okay, so here we have to understand about this one concept, the how this one affects time period. Time period means कि ਜਿਹੜਾ ਆਪਾਂ ਕਿਸੇ ਨੂੰ force ਲਾਉਣਾ, ਸਮਝੋ ਕਿ ਕਾਰ ਹੈ, we have pushed a car. It was earlier at 0 km per hour. Now we have changed it to 30 km per hour by pushing. Okay, and in how much time we applied the force? For example, we applied the force for 1 hour. So these are two things. Time period is there and change in momentum is there. Still we will discuss ke what is the effect of time on the force. Okay, so when we are understanding about this one time, we have to focus on the formula is equal to change in momentum. We write it like this way: P2 minus P1 divided by T. P2 means final momentum, P1 means initial momentum. Initial momentum, like when it was at 0. Final momentum means when it is force was applied, and after applying the force, what was its momentum. And T is the time period during which the force is applied. किन्ने time ਦੇ ਵਿੱਚ ਉਹ force ਜਿਹੜਾ ਲਾਇਆ ਆਪਾਂ, ਜਿਵੇਂ ਇੱਥੇ 1 hour ਦੇ ਵਿੱਚ ਲਾਇਆ. So what happens, आगे की होना है, कहते जी force is equal to P2 minus P1 divided by T. देखो फॉर्मूले तो की पता लगता है, जे आप P2 minus P1 ਨੂੰ ਹਟਾਈਏ, if we are going to remove P2 minus P1, that force is equal to 1 by T. If we now we have removed this one, so as to have the effect of force and time. Now this says, according to the formula, they are inversely proportional. When one physical quantity is in the numerator and the other one physical quantity in the denominator, then we call this one, then we call this one that these are inversely proportional. Inversely proportional means if one is less, other will be high. If one is one physical quantity, जिमें इत्थे time आ, ठीक है, एक physical quantity, other one, if time is less, force high. ਇਹਦੇ ਬਹੁਤ ਵਧੀਆ ਐਗਜ਼ਾਮਪਲ ਆ। ਦੇਖੋ ਟਾਈਮ ਘੱਟ ਹੋਊਗਾ, ਇਫ ਦ ਟਾਈਮ ਇਜ਼ ਵੈਰੀ ਲੈਸ ਦ ਫੋਰਸ ਵਿਲ ਬੀ ਵੈਰੀ ਹਾਈ। ਬਹੁਤ ਸੌਖੀ ਜੀ ਐਗਜ਼ਾਮਪਲ ਆ। ਕੀ ਐਗਜ਼ਾਮਪਲ ਆ? ਇਫ ਅ ਟੀਚਰ ਸਲੈਪਸ ਅ ਸਟੂਡੈਂਟ if a teacher slaps a student and the slap is he slaps very quick, the time of contact between the cheek and the hand is very less, so it hurts very much. And if the teacher slaps politely, means it takes a very long time so as to slap, calmly he slaps, then it takes much uh, longer time. When time becomes higher and it hurts lesser. Why it hurts lesser? Because the force which is transferred, that is very low. This is a germ example. These like examples you can have in your have in our society coming at very high speed. बहुत ज़्यादा high speed ਤੇ ਆਉਂਦੀ ਹੈ। ਉਹ ਇੱਕੋਦਮ ਵੱਜਦੀ ਹੈ, time of contact ਬਹੁਤ ਥੋੜਾ ਹੁੰਦਾ, ਬਟ ਉਹ ਬਹੁਤ ਜ਼ਿਆਦਾ ਆਪਾਂ ਨੂੰ hurt ਕਰਦੀ ਹੈ। Okay. This is, who is this table or trash? Okay. So the another example for this one is when we catch the ball. When we catch the ball, what we do, how the cricketers, the professionals, they do catch the ball. What they do, when they catch the ball, they drag their hand backwards, so it hurts lesser. Remember, they are dragging the, we are talking about catching a ball coming to that one there, and what they do, they drag their hands backward. So what happens, the ball just do not stops at once, it takes longer time t, it takes long time so as to catch. Now again the same case is there. If the time periods become higher, the force will become lesser. Got? Okay, is unable to understand, then you may tell. You just have to remember only these things. That in every example, when they increases time, the impact, what we can say, that the force becomes lesser. How the force becomes lesser? Because formula is to P2 minus P1 divided by T. If T is very large, force is very small. Opposite are there. In every case, we are increasing T, force is becoming lesser. Okay. The next one example which we are going to study. Next example is the person who is jumping, long jump or high jump. What they do have cushions. Cushion मतलब कि गद्दे रखे ਹੁੰਦੇ ਆ, और ही ਜਿਹਨੂੰ ਆਪਾਂ ਕਹਿੰਦੇ ਰੇਤਾ, cushion or the hay. Okay. So what happens? कोई गल नहीं, I think so now it's on live again. Earlier the small disturbance was there. Got? So what happens? A person jumps and rests on the cushion. So what happens? होना की है ਇਹਦੇ ਵਿੱਚ? देखो cushion ਦੇ ਵਿੱਚ ਕੀ ਹੈ? The person do not stops the the person do not stops at once. It goes down. ਥੱਲੇ ਤੱਕ ਜਾਂਦਾ ਹੈ। ਕੁਸ਼ਨ ਜਾਂਦਾ ਹੈ ਥੱਲੇ ਤੱਕ। Sometimes this is happening. I don't know why this one is happening, but don't worry. The cushion is going down and the time period is again increasing. So in these all the cases we are increasing time so as to lower the force applied. Okay. So these all were the applications of the Newton's second law. And the next question is, use of seat belts. Okay, so again we are discussing this and that, how seat belts helps us, because again what do you have to discuss, that a person will be sitting like this, driving the car, like this, and seat belt is around him. This is the seat belt. Sorry. Okay, seat belt is here. So what happens when a seat belt is applied, and if accidentally anything comes in the way, what happens? The car has to stop. Okay, so when the car stops, the person would also stop. But what happens? When the person, if there is no seat belt, then once ikko dam ruk juga with a jerk, time period will be very lesser. Force will be very higher. But what happens when we are having a seat belt? The person moves forward. When the person moves forward, that seat belts increases the time to stop. Remember what is the effect of seat belt? Seat belt increases the time to stop. Okay, so I'm really sorry for this one, but I don't know why the network is creating trouble. Okay, but I'm trying a lot to resolve this one trouble also. Okay, so please adjust for today. I will try to have another company sim so as to remove this one trouble. Okay, here is a seat belt, and as I told you, the seat belt increases the time to stop. When the time to stop increases, the force decreases. So these were the examples in which we use Newton's second law. In all the examples we have used Newton's second law. Okay, so now we have to discuss Newton's third law. Okay, it's a simple one. So first we will discuss examples related to Newton's third law. So what happens in Newton's third law? This law is used in the rockets, and the best example which you have used, that one is the rocket which you use in Diwali. On the occasion of Diwali, we use rockets, and the rocket goes towards the sky with the help of Newton's third law. Okay, so what is Newton's third law? Remember, in the Newton's third law, we will be having two things. For example, if we have a rocket and surrounding is air column, or a wall is there, a ball is there, ball. Ball example is very common. How? If you throw a ball towards the wall, why does it come back? Because we have thrown it towards the wall. Who is on the wall? Who is throwing it towards us? There is no one. But when the ball strikes the wall, it comes back to us. Why? The answer is, when the ball goes towards the when the ball goes and applies the force F. If F is 40 Newton, then what the wall will do? Wall will apply equal force on the ball. The wall will apply equal force on the, but the difference is of direction. When earlier the force was in this one direction, now the direction now the force applied by the wall is on the opposite direction. That's why the ball comes back in the opposite direction. So this is the Newton's third law. What does it say? It says that if you apply force on one thing, the other will also apply force on us. This is called action and reaction. So what do they say? For every action, there is equal and opposite reaction. हर एक एक्शन दे ਲਈ एक रिएक्शन मिलता है. Got? For every action, we got equal and opposite reaction. There are enormous examples related to this. The throwing a ball was first example. Next example which we discuss related to this, that one will be rocket example. Rockets. So in the rockets, what do we see? What we see, that the rockets give their exhaust in towards the back. Now what is in their back? Air. They pushes into this one direction, push ਕਰ ਦਿੱਤਾ, ਇਹਨੂੰ ਆਪਾਂ ਕਹਿੰਦੇ ਜੀ action, and in return the air applies the reaction. And remember, as if the push is of 5000 newton, the action is of 5000 newton, reaction will be of, action was in this one direction and reaction will be in the opposite, it will be same 5000 newton but in the opposite direction. ਤਾਂ ਕੀ ਹੋ ਜਾਊਗਾ ਕਿ ਆਪਣਾ opposite ਮਿਲਣਾ reaction, ਠੀਕ ਹੈ. So this is the Newton's second law and this one is the use, because due to rockets move upward due to this reaction, rocket moves upward due to this reaction करके ऊपर जाता है. If this reaction would have not been present, the object would have not been able to move. So there are enormous examples more. The other one, which one is common, that is recoiling of the gun. Recoil मतलब कि झटका मारना. Bullet from the gun the bullet goes onwards and the gun goes backward. So how does this happen? When the bullet goes forward, then what it do, it pushes the gun backward. When the bullet is going forward, for that one action, it gives a reaction in the backward direction. Bullet ने आगे जाना है. So this one was the other example for the recoiling the gun. The next example which we can discuss, that is of balloon. If we inflate a balloon, inflate मतलब कि balloon ਨੂੰ ਫੁਲਾ ਲਓ, ठीक है. Inflate balloon and release that one. The air will come back. When we release that one, air comes back. But ਆਪਾਂ ਕੀ ਵੇਖਦੇ ਹਾਂ ਕਿ balloon ਕੀ ਹੈ, it flies off away. So there is no motor inside the balloon, but still flown away ਤੋਂ ਬਾਅਦ ਕੀ ਆਪਾਂ ਵੇਖਦੇ ਹਾਂ ਕਿ ਉਹਦੀ ਸਾਰੀ ਹਵਾ ਬਾਹਰ ਨਿਕਲ ਚੁੱਕੀ ਹੁੰਦੀ ਹੈ. Deflated. So who helped it? The air which is inside. How this comes up? And pushes the outer air. When we got an action, then there is a reaction. Air pushes backward and the surrounding air pushes that one forward, and thus the balloon flies off away. So in these all the examples, there will be one pair of action and reaction. Got? So Newton's third law is about action and the reaction. pair in which one applies the action and in return it gets the reaction. Got? So the most important use of Newton's third law that is done by humans daily, every time we are using Newton's third law. How we are using? Even when you are walking, you uses Newton's third law. How? When we walk, consider this one is our feet. So tell me, in which one direction we apply the force for moving forward? ਆਪਾਂ ਜਾਣਾ ਇੱਧਰ ਆ ਤਾਂ ਫੋਰਸ ਆਪਾਂ ਕਿੱਧਰ ਲਾਉਨੇ? We apply the force backward. ਪਿੱਛੇ ਵੱਲ ਨੂੰ ਆਪਾਂ ਫੋਰਸ ਲਾਉਨੇ. ਫੋਰਸ ਲਾਇਆ. In return to this one force, what we get? ਆ ਜਿਹੜਾ ਐਕਸ਼ਨ ਮਿਲਿਆ ਆਪਾਂ ਨੂੰ, in to this one action we got a reaction. Okay, we applied the force backward and we applied the force backward on the floor and the floor applies a force forward and thus we move. So this is another example for the Newton's third law. And there is another example of rowing of boat. ਜਿਹੜਾ ਆਪਾਂ ਕਿਸ਼ਤੀਆਂ ਚਲਾਉਂਦੇ, ਠੀਕ ਹੈ, ਉਹਦੇ ਵਿੱਚ ਵੀ ਆਪਾਂ ਧਿਆਨ ਨਾਲ ਵੇਖੋ ਤਾਂ ਜਦੋਂ when we row, in which one direction we apply the force? We apply the force backward. Okay, we apply the force backward and the boat moves forward. Okay, so these were the two laws, Newton's second law and Newton's third law. In the Newton's third law we have discussed about the dependence of force, about the time, and in the Newton's third law we have discussed about the action and the reaction pair. Okay, so time has passed. It's 36 minutes of class is there, 4 minutes are left. For the last 4 minutes I will discuss with you about the problems which you are facing. Okay, for the problems please tell me about the troubles which you face. We are finding out this trouble. Okay, I will give an assignment to all the students and that one assignment has to be completed and given back to me. Okay, so how was today's topic? Please about that one give me feedback in the group. And very soon we will have the other one class, and if you will give me the feedback about any trouble, I will try to remove that one. Okay, so because you also please do send me the names of the students who were present, because still I am unable to mark the attendance. Okay, so with this one we are going to stop the class, but still we will revise what we have discussed. We have discussed two laws, Newton's second law and Newton's third law. So Newton's second law was, what is the effect of time on the force? There was the inverse effect. If time increases, force decreases. And there was enormous example in which time was increased so as to lower the impact of the force. The next one example which we discussed, that one was jumping, high jump, long jump. Okay, high jump was there, long jump was there, and catching of ball was there, and use of seat belt was also there. These all were the examples of the Newton's second law. And after this one we did discuss about the Newton's third law. And the Newton's third law, we did discuss that for action we got a reaction. And the most basic example, most basic use of Newton's third law is while walking. Remember, Newton's third law is used by us while walking, and we do not know that with which one law we are moving. We are moving with the help of the Newton's third law. We apply the force backward, and in return the floor pushes us forward. Got? So with this one we will end up the today's class. Thanks a lot all of you students, and please submit your feedback about the today's class. Thank you.